Hello everyone, and thanks for watching my videos. This video will be focusing on one important fundamental of general chemistry, which is Lewis electronic dot structure, which is a tools that we use to draw the covalent molecules and how the electron are arranged around the different atoms in a covalent molecules. So laws of structure is so important because if you can write the molecule, if you can identify the electron arrangements around the atoms, you will be able to understand the mechanism of how the reaction is taking place. Because at the end, what is a chemical reaction? It's a bond formation and a bond breaking. You break bonds in the reactant and you form bonds in the product. So rearrangement of bonds to form a new product, that is the definition of a chemical reaction. So if the reaction is involving covalent molecules, you are looking into the arrangement of the electron around these atoms in the molecules that's going to interact with each other. So we're going to be covering this very important fundamental of general chemistry. And so without further ado, here is the video, and I hope you enjoy it. Thank you.
Laws of structure basically is the main fundamental of the covalent bonding. You cannot write any covalent molecule without going through laws of structure fundamentals. So these fundamentals that we're covering here will apply to any covalent molecule, big or small. It will apply to macromolecules as long as it's covalently bonded. So what are the steps that you will follow to draw laws of structure for any covalent molecule? Imagine the covalent molecule coming, the atoms are coming with their electrons. These electrons are coming to participate in bonding. These electrons are known as the valence electrons. So each atom coming with its own valence electron, it's all gonna be shared in terms of total valence electron. So you have what's called total valence electron between the atoms in the molecule. So how you determine the total valence electrons? Not all of these electrons will be shared in bonding. Some of these electrons will be non-bonding electrons. So in order to write the correct laws of structure, you have to follow these steps in order. Do not jump any steps. Follow them in order. So what are the steps? Step one, count the total valence electron. How you count the total valence electron? By looking at the atoms in the periodic table. You know exactly what atoms you have in the molecule. When it says what is the total valence electron for carbon dioxide, you will look at the periodic table, you will see carbon is in group 4A. That means it has 4 valence electrons. Oxygen is in group 6A, has 6 valence electrons. So for carbon dioxide, you have 4 from carbon, 6 from oxygen, and you have 2 oxygen. So that would be 4 plus 12. That will give you total 16 electrons. So what you have right now in your total electrons is 16. This is the maximum numbers that you have. You cannot exceed it, and you cannot have less of it. The molecule at the end has to have this 16 valence electrons. As I said, it will be not necessarily bonding electrons. They will be between bonding and non-bonding electrons. But your total electrons on all the atoms has to be 16. So how we achieve that? How we achieve the total number of electrons are 16 is by going through these steps, as I mentioned. So step 2. So this is step 1, which is how much electrons we have out of all of these atoms as a valence electrons. Step 2, how are we going to connect the molecule? If you just have atoms around, how are you going to basically make a molecule? By connecting the atoms. How you connect the atoms? By a single bond. So you're going to start basically drawing line between the atoms. If this is a multi-electron atom, How are we going to decide which one is in the center? So if this is a multi-electrons, that's what we're doing right now, a polyatomic atom. So we have a polyatomic atom with multi-electrons. So we're going to basically decide on the central atom. So this is our first step. Decide the central atom. How you assign the central atom? By looking in the periodic table one more time. The least electronegative atom will be in the center. How we define the least electronegative? Here is the electronegativity table. The least electronegative atom will be on the left side, will be in the bottom. So if you are looking at non-metal here, if you're comparing fluorine to oxygen, then oxygen will be in the center. If you're comparing nitrogen to oxygen, then nitrogen will be in the center. If you're comparing carbon to nitrogen, then carbon will be in the center. So the least electronegative atom will be in the center, except hydrogen. Again, I'm looking at these because these are non-metal. We're only looking at these atoms here because we're looking into the covalent bonding, which is non-metal with non-metal. So hydrogen is a non-metal atom. So if you put hydrogen, why hydrogen cannot be in the center? Because hydrogen can have only one single bond. Atom in the center will be connected by multiple atoms. Hydrogen cannot be connected by multiple atoms. Hydrogen only can be connected by one single atom. So remember this. So in this case, we don't have hydrogen anyway, so we don't have to worry about that. We have carbon and oxygen, so we're good to go. Carbon is going to be in the center, connect the atom by a single bond. So this is a single bond, a single bond. So let's see how much we consumed so far from step 2. We have total 16. We made a single bond between carbon and oxygen, another single bond between carbon and the other oxygen, and that consumed 4 electrons. So far we used 4 electrons in this process. How many electrons are remaining? Will be 12 electrons. So at step 3, we have 12 electrons to still distribute. Where are we going to distribute these 12 electrons on? We're going to distribute them on the terminal atom. So you're going to satisfy the terminal atom first. So the step 3, assign the electron on the terminal atom. There is an exception here. What is the exception? Again, hydrogen. Hydrogen cannot be in the, has more than 2 electrons. Because hydrogen, again, if you look at the hydrogen, hydrogen is in row 1. And what is the maximum electron you can put in row 1? 2 electrons. So hydrogen cannot take beyond 2 because hydrogen has only 1 s. And the 1 s will be completely filled, and that's it. That's your first energy level. After that, all of these will reach octet. All of these is going to have 8 electrons surrounding the outermost. So that's why these atoms will follow the octet rule, but hydrogen will not follow the octet rule. So this is another exception for hydrogen. So as you can see, hydrogen has 2 exceptions. The first exception, hydrogen cannot be in the center. The second exception, hydrogen cannot be surrounded by 8. Okay, so remember these 2 exceptions. That's pretty much what you need to be looking for when you're dealing with hydrogen atom. So at step 3, are we completely consumed all the electrons? And the answer is yes. If you look at the step 3, we don't have any more electrons. So this is our structure right now with all the valence electron. Is this the right structure? Would you decide this to be the lowest structure of carbon dioxide? The answer is no. This cannot be the lowest structure for carbon dioxide. Why? Because carbon is not octet. How are you going to make carbon octet? You have to go to step 4 and step 5. You have the carbon. Now the carbon we need to look at the carbon to make sure it's octet. So the next step is to look at, do we have any extra electron? Is there are any extra electron that we can put on the terminal and the central atom? And the answer is no. We don't have any more electrons to put on the center because we already consumed all the electrons. So we have to go to step 5. So what is step 5? Is making a double bond and a triple bond. So we're going to make a double bond between this carbon and oxygen. How we make a double bond? By moving these 2 electrons here. We'll make a double bond. These 2 electrons here will make a double bond. because for every bond, you need 2 electrons. And if you look at carbon right now, how many electron carbon surrounded by? This is a double bond. How many electron in the double bond? 4 electrons. So this is a 4 electron bond. How many electrons in the double bond? 4 electrons. So 2 electron here, 2 electron here, that's 4 electrons. 2 electron here, 2 electron here, that's 4 electrons. So carbon right now is octet. So carbon is octet, oxygen is octet. Does carbon follow the octet rule? When you say an atom follows the octet rule, it means surrounded by 8 electrons. Clearly, carbon follows the octet rule. How many non-bonding electrons on carbon? And the answer is 0 non-bonding electron. Carbon doesn't have any non-bonding electrons. How many lone pair on carbon? And the answer is 0 lone pair. So far, carbon doesn't have any lone pair. Carbon doesn't have any non-bonding electrons. And why is that? Why carbon doesn't have any lone pair? Because we do not have any extra electron. This is how the atom will have a lone pair or non-bonding electron. If you have an extra electrons, we don't have any extra electrons. Why? Because we consumed all the electrons after step 3. Step 3 consumed all the electrons, so we don't have any more electrons to put on the molecule. Oxygen atom. How many non-bonding electron oxygen atom? All of these questions is answered by laws of structure. So drawing laws of structure is going to answer all of these questions. So step 1, valence electron. What is the total valence electron in water? Hydrogen is 1 times 2, why 2? Because you have 2 atoms. Oxygen is 6, so that will make a total of 8 valence electrons. So now you have a total of 8 valence electrons. So step 2, you're going to put the oxygen in the center, surrounded by the 2 hydrogen. Remember, hydrogen cannot be in the center. Step 3, do you need to put electrons on hydrogen? Step 3, no, this is already, hydrogen is already satisfied here. So you don't need to put any more electron on hydrogen. So you need to go to step 4. How many electrons remaining so far? We consumed 4 electrons. 2 electron here, 2 electron here. So we consumed 4 electrons. How many are remaining out of the 8? 4. Where are they going to go? On the central atom. Do I need to go to step 5? No. Why? Because the atom is already octet. You only go to step 5. I repeat, you only go to step 5 if the atom is not octet, if the atom has less than 8. So you only go to step 5 if the atom has less than 8 electrons, which means not octet, the same, which is the carbon dioxide here. In this example here, we went to step 5 because carbon was not octet, and we had to make a double bond or a triple bond. That would be laws of structure for water. And as you can see in that laws of structure, oxygen has 4 non-bonding electrons or 2 lone pairs. This is what you're looking at right now is chapter 8. What you're looking at right now is chapter 8. I repeat, you will not going to cover anything new except going from laws of structure into the molecular geometry. Chapter 8 is all about molecular geometry of covalent molecule. And it's from this step, you're going to basically determine the geometry. The next example was carbon tetrachloride. What is laws of structure for carbon tetrachloride? We're going to follow the same steps. Total valence electron. So you have 4 plus 4 times 7. Where the 7 come from? The group number of chlorine, 7A. So that will be 7 valence electrons. You have 4 atoms. So that's your total valence electron. This is very important. If you messed up in this, you're not going to get the right structure or the right answers because your starting point was incorrect. So I repeat, it is very important to be careful when you determine the valence electrons. And you don't need to memorize anything. It is the group number. Carbon is in group 4A, will have 4 valence electrons. Carbon in group 7A will have 7 valence electrons. You have 4 chlorine atom, 4 times 7 plus 4, that will be 32. Next step, who's going to be in the center? Carbon, surrounded by 4 chlorine. So 4 chlorine, 4 bonds. How many electrons we have so far? Out of the 32? 8 electrons. We have 8 electrons out of the 32. So we have a lot of electron remains. Where are they going to go? Next, the terminal atom. So step 3 goes on the terminal atom. What are you going to put on the terminal atom? It doesn't matter what these atoms are. You're always going to put 6 electrons. 6 electrons in each of these atoms. Unless it's hydrogen. That's the only exception. Right now, we don't have hydrogen, so we don't have to worry about anything here. So let's look at our structure right now. Did we finish all the 32 electrons or consume? And the answer is yes. 8 are in bonding. 6 times 4, 6 in each chlorine times 4, because you have 4 of them, that's 24. So that's it. Is carbon octet? Yes, carbon is octet, surrounded by 8. So we're good. So this is our Lozzo structure of carbon tetrachloride. Does carbon follow the octet rule? Yes. Is carbon has any non-bonding electrons? No, 0. Is carbon has any lone pair? 0. Okay, so this again will be Lozzo structure. Here is the next example for H2O positive. So you start with the same steps. Hydronium ion has 3 hydrogen, so 3 times 1, plus 6 from oxygen. And why you subtract 1? Why this subtraction of 1? Because you have positive. Every time you have positive, you subtract an electron. If this was negative, you add an electron. 3 times 1 plus 6 minus 1, that would be 8. Who's going to be in the center? Oxygen, surrounded by 3 hydrogen. Single bond, single bond, single bond. How many electrons you consume? 6 electrons. How many electrons remain? 2. Where are they going to go? In the oxygen. That's your Lozzo structure for hydronium ion. Is oxygen follow the octet rule? Yes. How many lone pair on oxygen? 1. How many non-bonding electron on oxygen? 2. So again, so you are following the steps regardless what the molecule is. Draw Lozzo structure for sulfur hexafluoride. So right now we're going to follow the same steps. So step 1, total valence electron, 6 plus 6 times 7. That will be 48 valence electrons. Step 2, sulfur in the center, surrounded by 6 fluorine. You connect the atoms by single bond. Clearly, you can tell from here that sulfur is not going to follow the octet rule. Sulfur is going to have more than 8 electrons. So as I said, not necessarily every single time the atom has to have 8 electrons. The atom can be surrounded by more than 8 electrons. Step 3, you satisfy the terminal atom by putting 6 electrons in each fluorine, and that will consume all your 48 electrons. So your 48 electrons are completely consumed in this case. So let's ask the question again. Does sulfur here follow the octet rule? The answer is no. How many electrons surrounding sulfur? 12 electrons. So clearly sulfur doesn't follow the octet rule. Sulfur atom here is surrounded by more than 8. How do you know that? 2, 4, 6, 8, 10, 12. Okay? Cl3. So here is ICl3. Here is the step 1, which is the valence electron. You have a total of 28 electrons. 7 from the iodine or the iodine, 7 from the chlorine times 3, and that will be 28. Iodine in the center, surrounded by chlorine, so you get Cl, Cl, Cl. The next step is satisfy the terminal atom. You got the idea by now. Step 4, assign any extra electron on the central atom. Do we have any extra electron? Let's count. 2, 4, 6. 2, 4, 6, 2, 4, 6, that's 18. So we have 18 here. 2, 4, 6, that will be 24 total. So 18 plus 6, that's 24. Do we have any remaining electron? Yes. How many? 4. Where are they going to go? On the central atom. Non-bonding electrons or 2 lone pairs. So iodine has 4 non-bonding electrons or 2 lone pairs. Does iodine follow the octet rule? The answer is no. Iodine doesn't follow the octet rule. Why? Because iodine has a total of 2, 4, 6, 8, 10. Iodine has a total of 10 electrons right now. So iodine doesn't follow the octet.
And thanks for watching my videos and liking and subscribing to my channel. Thank you.